Hello everyone, welcome back again. This is the squares and square roots part 3 division method, but this time we will be doing a number which is not a perfect square. Yes, it is possible to find a square root of not a perfect square. Yes, they have asked many questions in a textbook. As you can see, in question number 6, find the square root of the following, correct, up to 2 places of decimals. So they're going to ask questions for non-perfect square number in this way. So you have to find a decimal. You'll get a decimal, because a perfect square will not give us a decimal. Non-perfect square number will definitely give us a decimal. Now it will be totally based upon the question up to what places of decimal we have to find. Okay, so let's take one number. Let's say 7. Is 7 a perfect square? Definitely not a perfect square, correct? So let's do this. Is 7 a perfect square? No. Let's find this answer with the help of the division method that we have learned. The question will be asked like this: find the square root of 7. Okay, find the square root of 7 up to 2 places of decimal or 3 places of decimal. So I will do this sum. Okay, let's solve this. Now 7 is definitely not a perfect square, so you have to find a number, find a squared number which is very close to 7. I think that is 4. 6 is not a perfect square, 5 is not a perfect square, 2 is not a perfect square, but 4, because 2 into 2 is equals to 4. You might say, so 9 is a perfect square. Yes, it is a perfect square, but I cannot go beyond 7. So we have to make sure it is 7 or less than 7. Alright, so I think we'll do with 2 into 2 is equals to 4. Okay, 4. Subtract this, you get how much? 4, 5, 6, 7. You get 3 as your remainder. Now make sure you add this. The process remains the same. Please do not forget this. You add 2 out here, you get 4. Now as you can see, you have no numbers after 7. You have run out of numbers. You put a decimal out here, and then you put a decimal out here, and then you add the zeros, just like the division method which we used to do in junior classes. In the same way you will do it, but the only difference over here is that since we're talking about squared numbers, we will add, instead of one number, we'll add 2 zeros. We'll also add in pair. Okay, 2 numbers you will add to make 1 pair. Over here you add 2 zeros to make 1 pair of 0. Okay, and then you bring this 0 down. This 3 becomes 300, as you can see. Okay, now you can divide this 300 by 4. Definitely that time it was 3, it was less than 4, so it was not possible, and then there was no number beyond 7. So now you can do it. Let's continue. And now you have 300, and then you have to see what is a number. There's already a 4, and then one more digit number. When you multiply with the same digit, it will give us equal to or less than 300. So 4 is already there, and then a digit multiplied by the same digit, that's what we have learned till now, to give us nearest to or equal to or less than 300. So let's start with let's say 3. Okay, 3 into 3 equals 2. Multiply the same, and 3 into 3 is 9. 3 into 4 equals 12. You get 129. I think we can raise the number. Let's start with 5. Let's do it 5. 45 into 5. Same number you have to take. 5 into 5 equals to 25. And then 20 plus 2 equals to 225. Okay, and then let's see this answer. I think it's very close to 300, but then should we try one more number with 6 over here? Let's do this. Let's see how much we'll get. Another digit, that will be 6 over here. Okay, 6 into 6 equals to 36, and then 4 into 6 is 24, 24 and 5 and 6 27. See, it is very close. So 46 into 6, let's check once more. 6 into 6 equals to 36. 6 4 and 24, 24 25 26 27, 276. See, it's very close. Should we try one more? I think we should try 40 7. Okay, the another digit number, let's take 7 multiplied by 7. Let's see how much we'll get. 7 and 7 equals to 49. Okay, and 7 into 4 is how much? 7 into 4 into 7 plus 28. 28 plus 4 equals to 32. This we cannot take because we are going beyond 300. This we cannot take because there is another number, 46 into 6, which is very close to 300. So I think this is the correct number. Let's write 46 into 6 will give us 276. Very close to this number. Okay, so other numbers I can just erase this. Okay, and then this 3 is also not required for now. Alright, now let's continue with the process, and then let's subtract this. Okay, this is 10, so 10 minus 6 will give us 4. Okay, and this is 9, so 9 minus 7, 7, 8, 9, this is 2. Okay, and this is nothing because this is 2 minus 2 will give us nothing. And then do not forget to add 6 out here, since you have taken 6 as another digit. 6 plus 6 is 12 plus 1. Okay, and then 4 plus 1 is equals to 5. 52. Okay, now since 24 is less than 52, so what we can do is we can add one more pair of 0 like this, and then let's bring this pair down out here. This will be 2400. Alright, so let's see what multiplied by 52 something multiplied by 502 something multiplied by something, same number, should give us nearest to 2400. Let's try this. Let's try with 5 only. Okay, let's raise the bar, and then let's try with 5 only. 5 into 5 is equals to 25. Carry over 2. 5 into 2 is equals to 10. 10 plus 2 is equals to 12. Carry over 1. 5 into 5 is 25. 25 plus 1 is 26. 2625. So I think this is a very small number, as we have, oh, I'm very sorry, 2400 we want, and we are getting 2625. So it's a very big number, so we cannot take this. Instead of 5, we have to decrease the number to 4, 3, 2, 1. Okay, we'll try that. Let's decrease to, let's say, a 4. Okay, let's see how much we'll get. So 4 into 4 is equals to 16. Carry over 1. 4 into 2 is 8. 8 plus 1 is 9. And 4 into 5 was 20. I think this is one very close number. Let's take this. Okay, because 5 was very big. Now 4, another number less than 5 is 4. So this is what we were going to take. So 2.6. Okay, already got 524 multiplied by 4 will give us 2096. Okay, again this will, that you will get the remainder. Since it's not a perfect score, this will go on. Now the question depends upon how many places of decimal do you require. Over here I've got 2 places of decimals. Now you see I've got 2.64. okay, if I had asked please find the answer in one place of decimal, so now for one place of decimal you have to find 2 places of decimal in the process, and then use the process of rounding up. So how do we use rounding up? We check the last number of the digit, that is 4, that is which is less than 5. Okay, if the number, the last digit number is less than 5, the number in the front will not increase. But if the last number is greater or equal to 5 and above, the number in the front will increase. In my case, it is not greater than 5. The number in the front will remain same. So one place of decimal I have obtained. 2.6 is your answer. If they ask 2 places of decimals in the process, over here you have to find up to 3 places of decimal and then use a rounding up process. I'll explain round up process again. If you get the answer as 2.65, now see over here, and I say find the answer in one place of decimal, we have to round it up. Check the last number is 5 out here. Okay, if the number last number is greater than or equal to 5, the immediate number in the front will increase by one number. That means this 6 will become 7. That means your final answer is 2.7. That's what they're asking, one place of decimal. Okay, I hope you have understood. And then there are many sums like this. Please try it. For you don't have to find up to 5 places or 6 places of decimals. Things will become very complicated. If you understand the concept over here, that is more than enough. I've done one example for you, root 7. Over here in the book there is root 2, root 3, root 8, root 11, root 35, root 99. So please do all this and then please get the answer. And then don't forget, they have asked in 2 places of decimals. I've stopped it over here. If you have to find 2 places of decimals, you do the one more process. You have to find 3 places of decimals and then round it up and then get the answer. Okay, so class, I hope you have understood. All the class 8 students, if you still haven't understood, let me know and then I'll help you with another question. Thank you very much. I hope you have understood.